Hello friends, welcome to my course on microbial biotechnology. We are in module 12 discussing patenting in microbial biotechnology. In this lecture, we will be dealing with patenting in microbial biotechnology, the commercialization aspects and the future of microbial patenting. The lecture is divided into 4 sections. Section 1 deals with patenting in microbial biotechnology. Then section 2 deals with needs of patenting in microbial biotechnology. Section 3 deals with the commercialization of patents in microbial biotechnology, and section 4 will be discussing about the emerging trends and future direction. Let's start with section 1, patenting in microbial biotechnology. We discuss about patentable subject matter in microbial biotechnology, microorganisms, genetic modifications and bioprocesses. Then microbes patenting, historical development in microbes patenting, specific challenges in patenting microbial innovations. Then some case studies, particularly with respect to antibiotics and industrial enzymes. A patentable subject matter in microbial biotechnology. In microbial biotechnology, the scope of patentable subject matter is broad but must meet specific criteria. The following categories are commonly considered for patent protection. Number 1, microorganisms. These include naturally occurring microorganisms that have been isolated and purified, as well as genetically modified microorganisms engineered to perform specific functions such as producing antibiotics or degrading environmental pollutants. The patentability of microorganisms was solidified by the US Supreme Court in the Diamond versus Chakraborty 1980 case, which we have discussed slightly in the earlier lecture. This set a precedent for patenting living organisms. The second most important thing is the genetic modifications. This category encompasses genetic sequences, vectors, plasmids and recombinant DNA that result in a new or improved microorganism. Innovations in gene editing such as CRISPR-Cas9 have also led to patents covering specific genetic modifications in microorganisms. Then comes the bioprocesses. Patents can be granted for bioprocesses or processes that utilize microorganisms for industrial, agricultural or pharmaceutical applications. Process patents in microbial biotechnology often focus on optimizing yield, efficiency or cost effectiveness. For example, fermentation processes for producing biofuels, enzymes or therapeutic compounds are patentable. Now let's go into microbes patenting. Patenting of microbes is a process that allows the creators or developers of new and useful microorganisms such as bacteria, virus, fungi and other microorganisms to obtain exclusive rights to use and sell their inventions for a specific period of time. Patenting microbes has become increasingly common in recent years, especially in the field of microbial biotechnology. It provides companies and individuals with an incentive to invest time and resources into developing new and useful microbes with specific functions. Let us look into historical development in microbes patenting. Earlier we have discussed about the patenting in biotechnology overall in the earlier lecture. So let's start with the Budapest Treaty in 1977, which is an important treaty. Then the landmark Diamond versus Chakraborty case in 1980, followed by the first microbial patent granted in 1983. Then the European Patent Convention in 1986 happened, and the Human Genome Project started in 1990 was coming towards a conclusion towards the end of the last century. And of course, it was completed by 2023, and in 2000 there was a biotech boom, and in 2010 the emergence of synthetic biology are important milestone in the development of the history of microbial patenting. In 1998-77, the international recognition for deposit of microorganisms was recognized by the Budapest Treaty. This is also known as the Purposes of Patent Procedure, signed in Budapest, Hungary on 28 April 1977, and it was enforced on 9 August 1980 and was later amended on 26 September 1980. The treaty is administered by the World Intellectual Property Organization. The treaty allows deposits of microorganisms at an international depository authority, IDA, to be recognized for the purposes of patent procedure. We have mentioned about this briefly in the earlier lecture too. As of December 2023, 89 countries were party to the Budapest Treaty. What are the key features of the Budapest Treaty? There is a single deposit requirement. We do not have to deposit in every country. then it has international recognition and there is assurance of confidentiality and accessibility. So, a single deposit of the microorganisms in an IDA anywhere in the world, at least those countries which are signatories, fulfills the deposit requirements for patent applications in all contracting states. The treaty is recognized by over 80 countries, making it easier for inventors to secure patent protection in multiple jurisdictions. This number has gone to 89 by 2023 December. The IDA maintains the microorganisms under conditions that ensure its viability and accessibility while protecting the invention's confidentiality. So, let us now revisit a Diamond versus Chakraborty case. The non-patentable status of living organisms changed with the Landmark decision of the Supreme Court of USA in this case, when a genetically modified bacterium was granted a patent. Anand Chakraborty worked as a scientist at General Electric. He developed a genetically engineered bacterium capable of breaking down crude oil. The argument while giving judgment was that the patent claims made by Chakraborty were of three types. First, process claims for the method of producing the bacteria. Second, claims for an inoculum comprised of a carrier material floating on water such as straw and the new bacteria. Third, the claims to the bacteria themselves. The patent examiner allowed the claims falling into the first two categories, but rejected claims for the bacteria. The decision rested on two grounds. One, microorganisms are products of nature. Living things are not patentable, subject matter under 35 USC 101. In a 5-4 ruling, the court ruled in favor of Chakraborty and upheld the patent, holding that a live human-made microorganism is patentable subject matter under Title 35 USC 101, and respondent's microorganism constitutes a manufacture or composition of matter within that statute. So, the judgment as given by Chief Justice Warren E. Burger, who wrote the decision, and was joined by Potter Stewart, Harry Blackmun, Williams Rehnquist, and John Paul Stevens. They wrote the interpretation of 35 USC 101, which says, whoever invents or discovers any new and useful process, machine, manufacture or composition of matter, or any new and useful improvement thereof may obtain a patent thereof subject to the conditions and requirements of this title. In 1983, the first microbial patent following the Diamond versus Chakraborty decision was granted for a genetically engineered microorganism. This patent assigned to General Electric covered the oil-eating bacterium developed by Chakraborty. In 1986, the European Patent Convention was amended to explicitly allow the patenting of biological material, including microorganisms, and laid groundwork for the patenting of microbes in European countries. Towards the end of the century, the Human Genome Project was completed around 98% and fully completed in 2003, which marked a significant milestone in genetic research. This project provided insights into the genetic makeup of various organisms, including microbes, and contributed to the development of new genetic engineering techniques. And by 2000, there was a biotech boom in biotechnological research and innovation, including the engineering of microbes for producing pharmaceuticals, biofuels, enzymes, and other valuable products. Then came the era of synthetic biology in 2010. The field of synthetic biology gained prominence, allowing scientists to design and engineer microorganisms with custom-made genetic sequences to achieve specific functions. The advancements in genetic engineering techniques, as they were improving, scientists gained the ability to manipulate microorganisms' genetic material more precisely, which led to the development of various genetically modified microorganisms for application in medicine, agriculture, and industry. Then comes the gene editing technology, the CRISPR-Cas9 technology. This revolutionized genetic manipulation, including in microorganisms, allowing for precise and targeted modifications. And there was a surge in patent filing steadily related to microbial biotechnology, which includes patents for new microbial strains, genetic modifications, fermentation processes, and application in various industries. However, the field suffered from ethical and regulatory challenges as it advanced. These Ethical and regulatory considerations surrounding the patent of living organisms, especially genetically modified microbes, gained attention, which was very important and necessary. These discussions included concerns about biosafety, environmental impact, and the potential for unintended consequences. Then came the era of international cooperation, where organizations such as Patent Cooperation TD and the World Intellectual Property Organization have facilitated the process of filing and obtaining patents for microbes across multiple countries. What are the specific challenges in patenting microbial innovations? Patenting microbial innovations presents several challenges that are unique to the field. Number one is the naturally occurring microorganisms. A fundamental challenge is the patentability of naturally occurring microorganisms, which are more of a kind of discovery and not invention. This can be patented if isolated and purified, and must demonstrate novelty, utility, and non-obviousness, which are the basic features of any subject matter to be patented. The US Supreme Court's ruling in Association for Molecular Pathology versus Myriad Genetics 2013 limits the patenting of naturally occurring genetic material, which has implications for microbial patents. The next most important thing is the patent scope and breadth. Determining the scope of a microbial patent can be complex. Broad patents may cover an entire class of microorganisms for bioprocesses, potentially stifling competition and innovation. Narrow patents may limit the commercial value of the invention. So, these are some of the challenges. Then important point is reproducibility and deposit requirements. Microbial patents often require a detailed description of the invention and reproducibility of the results. This can be challenging when dealing with complex biological systems. Many jurisdictions require the deposit of the microorganisms in an internationally recognized culture collection to meet legal requirements. Ethical and environmental concerns are also important issues in challenging. Ethical issues related to the patenting of microorganisms, particularly GMOs, can influence the patenting process. Environmental concerns about the release and use of GMOs may also affect the regulatory landscape, potentially impacting patent eligibility and enforcement. Let us now have some case studies where significant patents in microbial biotechnology are involved. Number one is the antibiotic, example penicillin. One of the earliest and most significant microbial patent was for the process of mass producing penicillin, an antibiotic derived from the mold Penicillium. The patent filed in the 1940s played a crucial role in the widespread availability of penicillin, revolutionizing medicine and saving millions of lives. Let us now examine about some industrial enzymes like amylase. Enzymes produced by microorganisms are widely used in industries such as food processing, textiles, and biofuels. For example, patents on amylase and an enzyme used to break down starches have led to more efficient production processes in the food and beverage industry. Companies like Novozymes have built extensive patent portfolios around microbial enzymes, driving innovation in industrial biotechnology. So, you can see here the Novozymes patent portfolio growing every year. Here the number seems to be dipping, but it may be because the patent process takes time and the patents has not yet been published online. Then comes the case of bioremediation, which are oil-eating bacteria. For example, patenting of microorganisms for environmental applications such as bioremediation has led to significant advancements. One notable case is the patent for Pseudomonas putida, which is genetically engineered bacterium capable of degrading oil spills. And you already know about this famous Diamond versus Chakraborty case. And this patent associated with Diamond versus Chakraborty case underscored the commercial potential of genetically modified microorganisms in addressing environmental challenges. Let us also have some examples from agricultural biotechnology like BT crops. The patenting of genetically modified crops such as those expressing Bacillus thuringiensis toxin, which is derived from a microbe basically, for pest resistance has transformed agriculture. These crops reduce the need for chemical pesticides, offering a more sustainable farming solution. Patents on BT crops have been highly lucrative, though they have also sparked debates over the ethics and environmental impact of GMOs. So, here this patent we can see Bacillus thuringiensis toxins with improved activity granted under the United States Patent Act. Now, let us discuss about the need of patenting in microbial biotechnology. What is the requirement to attain a microbe patent, microbes patenting in India, advantage of microbes patent, then disadvantages and ways to navigate the future of microbial patenting. What is the need for patenting in microbial biotechnology? Number one, it protects intellectual property. It provides incentive for innovation and provides market exclusivity and leads to economic growth and job creation and triggers commercialization and investment. And it involves technology transfer and licensing, collaboration and partnership and public disclosure of inventions, and overall it solves global problems. So, how it protects intellectual property? Patents provide legal protection for novel and inventive microbial based inventions. They grant exclusive rights to the patent holder, allowing them to prevent others from making, using, selling or importing the patented invention without permission. This protection encourages investment in research and development by providing a mechanism to recover cost and realize profits. It provides incentive for innovation. Patents serve as a powerful incentive for researchers, scientists, companies to invest time, effort and resources into developing new microbial biotechnology solutions. The potential for exclusivity and commercial gain motivates innovation, leading to the discovery of new products, processes and technologies. The commercialization and investment facilitates the commercialization of microbial inventions. They provide a means for inventors and companies to attract funding and investment, as investors are more likely to support ventures that have a strong intellectual property portfolio. Then comes technology transfer and licensing. Patented microbial technologies can be licensed or sold to other entities for use, further development or commercialization. This enables the technology transfer, allowing smaller companies or research institutions to benefit from and build upon existing innovations. It also provides collaboration and partnerships. Patents can facilitate collaborations and partnerships between different stakeholders in microbial biotechnology such as academia, industry and government. Collaborations can lead to the sharing of expertise, resources and ideas, which can accelerate the development and applications of microbial technologies. Patents help in solving global challenges. Microbial biotechnology has the potential to address various global challenges such as food security, environmental sustainability and healthcare. Patents encourage the development of innovative microbial solutions that can contribute to solving these challenges. In exchange for the exclusive rights granted by a patent, inventors are required to disclose their inventions, details and how it works. This information becomes part of the public domain, contributing to the collective knowledge base and promoting further research and development. Patents provide a period of market exclusivity during which the patent holder can establish a dominant position in the market. This exclusivity can lead to increased market share and revenue opportunities. Patents offer economic growth and job creation. The protection and commercialization of microbial inventions can lead to economic growth, job creation and the development of new industries and markets. Now, what are the requirements to attain a microbe patent? Number one, it has to be novel. We already discussed in the last class. The microbe must be new and not previously known to the public, meaning it should not have been disclosed anywhere in the world before the filing date of the patent application. This includes any prior publications, presentations of public uses by the inventor himself. Then there is a need for an inventive step, which is actually non-obviousness. The microbial invention must involve an inventive step, which means it should not be obvious to a person skilled in the relevant field. The invention must demonstrate a significant departure from existing knowledge or solutions. Then comes the utility point or industrial applicability. The microbial invention must have a practical industrial application. It should be useful and capable of being used or made in a specific field such as agriculture, medicine, energy or environmental protection. The microbe has to be man-made. It must have been created or modified by human intervention rather than being found in nature. Now, how do you proceed in this whole process, first we have to determine the patentability, then document the invention and choose the right type of application. For determining patentability, before proceeding with the patent application, we need to conduct a thorough search to determine if the microbial invention is novel and non-obvious. This step helps to understand the existing state of the art and assess the potential patentability of the invention. We keep detailed and well documented records of the microbial invention, including the development process, experimental results and any modifications made to the microorganisms. Then depending on the situation and the level of development of the microbial invention, we choose to file either a provisional patent application or a non-provisional complete patent application. A provisional application provides an early filing date and gives time to further develop the invention before filing a complete application. Let us now examine the scenario of microbes patenting in India. Patent Act of India 1970 section 2 1J 34 defines an invention as a new and useful manner of manufacture or a substance produced by manufacture. India joined the Budapest Treaty on 17 December 2001. MTCC, Microbial Type Culture Collection and Gene Bank of the Institute of Microbial Technology, Chandigarh, IMTech, a CSIR institute, acquired the status of an IDA on 4 October 2002, marking the amendment of existing systems in India. The Government of India enabled patenting of microorganisms under its jurisdiction through the Patents Second Amendment Bill 2002, which was passed by the Parliament on 14 May 2002. In addition to IMTech, MTCC, India has two more international depository authorities. Number one is the National Center for Microbial Resources, NCMR. This national facility is funded by the Department of Biotechnology, Government of India, and affiliated with the National Center for Cell Science, Pune, NCMR, is a member of the World Federation for Cultural Collections and is registered with the World Data Center for Microorganisms. It was recognized by the World Intellectual Property Organization as an international depository authority in April 2011. Then we have the National Agriculturally Important Microbial Culture Collection, NAIMCC. This unit operates under the ICAR National Bureau of Agriculturally Important Microorganisms in Maunat, Bhanjan, UP. It falls under the aegis of the Indian Council of Agricultural Research and the Department of Agricultural Research and Education, Government of India. NAIMCC acquired the status of an international depository authority by WIPO under Article 7(1) of the Budapest Treaty, effective from July 28, 2020. These additions have enhanced the capabilities and resources for microbial research and preservation in India. Now, what is the procedure for obtaining or filing a patent? Filing the patent application, submit the patent application to the Indian Patent Office. The application can be filed online or physically at one of the patent office branches. There is option to file a provisional application which establishes an early filing date and allows more time to finalize the invention details. Then there is examination request. If a provisional application has been filed, a request for examination within 48 months from the date of the provisional application should be filed. For complete applications, the examination request should be filed at the time of application submission. Then comes the publication. Once the patent application is found to be in order, it will be published in the official patent journal after a period of 18 months from the filing date or priority date, whichever is earlier. Then comes the opposition phase. After publication, third parties have the opportunity to file pre-grant oppositions within a specified time frame, usually within 4 months from the publication date. Oppositions allow third parties to challenge the patent application's grant by providing reasons for its objections. Then comes the last phase, the grant of the patent. If the examiner is satisfied with the application and any objections are resolved, the patent will be granted. Then we have to pay the required grant fees to finalize the process. Then comes the maintenance phase, and once the patent is granted, the patent provides exclusive rights to the microbial invention for a period of 20 years from the filing date. To maintain the patent's viability, maintenance fees need to be paid as per the schedule set by the Indian Patent Office. Let us now discuss about the points to be considered prior to application. The procedure and requirements can differ significantly from one country to another. Consulting with a qualified patent attorney who specializes in biotechnology and intellectual property law is highly recommended to navigate the patenting process successfully and ensure that your microbial invention is adequately protected. What are the advantages of having microbe patent? It provides exclusive right. A patent provides the patent holder with exclusive rights to use and sell the microbe for a specific period of time, usually 20 years from the date of filing the patent application. It provides incentive for investment and development. Patents can provide incentives for companies and individuals to invest time and resources into developing new and useful microbes. It offers protection from infringement. A patent provides the patent holder with legal protection against infringement, allowing them to take legal action against anyone who uses, sells, or makes the patented microbe without permission. It provides commercialization opportunities. Patents can help to commercialize new microbes, allowing companies and individuals for making profit from their investments and developments in this field. Finally, it promotes innovation. Patents can help to promote innovation in the field of microbiology by encouraging companies and individuals to create and develop new microbes with specific functions. What are the disadvantages of microbes patent? The cost is very high. The process of obtaining a patent for a microbe can be expensive and time consuming, requiring significant financial resources and legal expertise. It suffers from ethical concerns. Patenting microbes raises ethical concerns as it may limit access to useful microbes and restrict the sharing of knowledge and information in the field of microbiology. Then the limited availability of microbes. Patents can limit the availability of certain microbes as the patent holder has exclusive rights to use and sell the microbe, resulting in higher cost for research and development as well as decreased access to useful microbes. Then there comes the legal challenges. Patenting microbes can result in legal challenges and disputes as the patent holder may take legal action against anyone who uses or sells the patented microbe without permissions. And it suffers from controversy. Patenting microbes is a controversial issue, and the potential advantages and disadvantages must be carefully considered before pursuing a patent. So, let us look into the challenges and issues. Biosafety and environmental concerns. Patenting genetically modified organisms might require rigorous assessment of potential risks and mitigation strategies, as they could have unintended environmental impacts, raising biosafety concerns. And the rapid technological advances in microbial biotechnology means that patent offices and legal frameworks may struggle to keep up with the new developments, leading to uncertainties in patent examination and enforcement. Then the variation at the international level. The patent laws and regulations may vary between countries, which can complicate the process of obtaining and enforcing patents for microbial inventions on a global scale. The requirement for public disclosure in patent applications may inadvertently lead to prior art that could impact the patentability of an invention, particularly in fast moving fields like microbial biotechnology. Patenting living organisms, especially GM microbes, can raise ethical and moral concerns, and hence balancing the potential benefit of microbial inventions with ethical considerations is significant and challenging. What are the ways to navigate the future of microbial patenting? There should be clear patent claims and descriptions. This helps reduce ambiguity and ensures that patents are enforceable. Encourage open dialogue among scientists, policymakers, ethicists, and the public to ensure the patent applications involving genetically modified microbes are well balanced and aligned with public values, and so it complies with ethical and societal considerations. Then the guidelines for novelty and non-obviousness. Develop specific guidelines for assessing the novelty and non-obviousness of microbial inventions, taking into account the rapid pace of technological advancements in biotechnology. What is prior art and patent databases? These aid patent examiners, inventors, and researchers in assessing the state of the art and avoiding duplication. Standardization for deposition of the microorganisms. Implement standardized procedures for depositing microorganisms in recognized culture depositories, particularly IDAs, ensuring reproducibility and accessibility for other researchers. Then comes the biosafety and environmental impact assessment. This helps address potential risks associated with the release of modified organisms in the environment. Another important issue is the international harmonization. This can streamline the patenting process and reduce inconsistencies. Then comes collaborative research and licensing, which encourage collaborative research and technology sharing among researchers, institutions and industries, develop flexible licensing mechanisms that allow for responsible use and commercialization of microbial inventions while promoting innovation. One important aspect is education and training. Providing training and educational resources for inventors, patent examiners and legal professionals in the field of microbial biotechnology ensures a better understanding of the technology and its patenting nuances, and there is a need for regular updates and review. So, for this we establish mechanisms for regular updates and reviews of patenting guidelines and procedures in light of scientific advancements and ethical considerations. Then there has to be public engagement and participation, involving the public in decision making process related to patenting genetically modified microbes, and seek input from diverse stakeholders to ensure that policies and regulations align with societal values. It provides support for startups and small enterprises. Providing support, guidance and incentives for startups and small enterprises to navigate the patenting process and protect their microbial inventions are very important. We also need to encourage responsible innovation, foster a culture of responsible innovation by encouraging researchers and companies to consider the potential benefits and risks of their microbial inventions. Let us now go to section 3, where we will be discussing about the commercialization of patents in microbial biotechnology. We will discuss about the evaluation of patents and licensing agreements, the technology transfer and collaborative research, strategies for commercialization, particularly startups, joint ventures and spin-offs, and also have some case studies of successful commercialization of microbial biotech patents. So, valuation of patents and licensing agreements. Let us start with the importance of valuation. Valuation of microbial biotechnology patents is crucial for determining their potential economic return. Accurate valuation informs licensing negotiations, mergers and acquisitions and strategic business decisions. The value of a patent is influenced by scope of claims, the market demand, competition and remaining life of the patent. What are the approaches of monetization? Patents can be monetized through various channels by simply outright sales. Then comes exclusive or non-exclusive licensing agreements as collateral for securing financing. The choice of monetization approach will depend on the patent holder's business strategy, the patent's market potential, and the common methods for valuing patents are the strategic role of the patent within a company's broader IP portfolio can significantly influence its value. A discounted cash flow estimates the present value of future income generated by the patent. Then market comparables assess the value based on similar patents. Then the cost based approaches, where we consider the investments made in developing the patented technology. Technology transfer and collaborative research. The role of technology transfer: number one, it enables the commercialization of innovations developed within the academic and research institutions. Number two, it involves the movement of scientific discoveries from the lab to the marketplace, often through partnership with industry. And number three, it leads to the development of new products, processes and technologies that can address significant societal needs. What are the mechanisms of technology transfer? Number one is the common technology transfer mechanism, which include licensing agreements, joint development agreements and research collaborations. The research institution licenses its patents to a commercial entity for development and commercialization under licensing agreements. In the case of joint developments, both parties collaborate to further develop the product. Then under collaborations allow for co-development of the new technology. Each mechanisms requires clear terms regarding IP ownership, scope of rights and revenue sharing to avoid future conflict. Collaborative research in microbial biotechnology is essential for advancing innovation, particularly in complex areas such as genetic engineering and microbial ecology. It involves multiple stakeholders including universities, government agencies and private companies. Managing IP rights in such collaborations can be challenging and requires careful negotiation to avoid disputes over patent ownership and commercialization rights. What are the strategies for commercialization? It can be commercialized through startups by the inventors themselves, or by establishing joint ventures or creating new spin-offs. Startups are a common commercialization pathway for microbial biotechnology innovations, particularly those emerging from academic research. These companies leverage novel technologies to attract venture capital, strategic partnerships and eventually market entry. Some of India's biotech startups, Zumutor Biologics, Pandoram Technologies, C6 Energy, Xcode Life Sciences, Biome Therapeutics and Oncosystem Diagnostics. But the Indian startup scenario is becoming a very happening place right now, particularly in the life sciences, due to very supportive programs by agencies like BIRAC. Startups benefit from their agility and focus on innovation, allowing them to rapidly bring new products to markets. They face challenges such as securing funding, navigating regulatory pathways and building a strong IP portfolio. Then comes the joint ventures. They involve collaboration between established companies and research entities, pooling resources, expertise and IP to bring microbial biotech products to market. This model is particularly advantageous for sharing risks and costs associated with product development and commercialization. Joint ventures can also accelerate market entry by combining the strengths of the partners, such as one partner's research capabilities and others' commercialization expertise. Then there are the spin-offs. Larger corporations often create spin-offs to commercialize microbial biotech innovations that do not align with their core business strategies. Spin-offs allow for focused development and commercialization while benefiting from the parent company's initial investment and support. This strategy can be particularly effective for advancing niche technologies that require dedicated resources and specialized knowledge. Some of the examples of spin-off by pharmaceutical companies in India can be seen in this table. We will not go through the full details of it. You can go through the PowerPoint presentation or this particular slide. So, let us now have some examples of the successful commercialization of microbial biotech patents. Antibiotics from microbial sources, industrial enzymes, genetically modified organisms are some of the microbes and products which have been commercialized. Antibiotics, for example, the commercialization of antibiotics derived from microbial sources such as penicillin is one of the most significant successes in microbial biotechnology. Antibiotics have saved countless lives and generated substantial economic returns. The success factors include strong IP protection, strategic partnerships and effective scaling of production. The commercialization of industrial enzymes such as those used in food, detergents, processing and biofuels are important examples. Patents in this area have enabled companies to secure market leadership and drive innovation. The success factors include the ability to patent the enzymes as well as the production process and applications, supporting long-term commercial success. The patents on genetically modified microorganisms used in agriculture, waste treatment and industrial process illustrate the potential of microbial biotechnology. This involves complex regulatory environments, strong IP protection, gives advantages by securing market exclusivity and support the investment for regulatory approval and commercialization. We come to section 4 where we will be discussing emerging trends and the future directions. Here we will deal with the patenting in synthetic biology and CRISPR-Cas technologies, the role of artificial intelligence in biotech patent analysis and prior art searches, the future challenges in biotechnology patent law, the impact of open science and open innovation on intellectual property. What are the emerging trends and future directions? Synthetic biology involves the design and construction of new biological parts, devices and systems as well as the redesign of existing natural biological systems. The patenting of synthetic biology innovations poses challenges due to the complexity and novelty of the technologies. Patents in these field often cover engineered microorganisms, gene circuits and synthetic pathways. but they must navigate issues of patents eligibility, especially regarding the distinction between natural and man-made products. Other emerging trends are the CRISPR-Cas technologies, which have revolutionized gene editing, enabling precise alterations to DNA in various microorganisms. The patent landscape for CRISPR-Cas technology is highly competitive and complex, with significant legal battles over foundational patents. What are the challenges? Both synthetic biology and CRISPR-Cas technologies raise questions about patent scope, especially concerning multi-gene editing, off-target effects, and potential dual-use applications, civilian and military. These technologies challenge existing legal frameworks, necessitating new guidelines and standards for patentability. The role of artificial intelligence in biotech patent analysis, prior art searches are the new emerging trend. AI is used to analyze biotech patents for identifying relevant prior art, predicting patentability, and assessing the strength of patent portfolios. Rapidly process vast amount of data, uncovering hidden connections between patents and prior art, valuable in complex fields like biotechnology, where innovations often involve multidisciplinary knowledge. AI enhances the efficiency and accuracy of prior art searches by utilizing natural language processing to analyze patent literature, scientific publications, and other relevant documents. AI tools can identify prior art that might invalidate patent claims or highlight potential infringement risks, thus influencing patent prosecution and litigation strategies. It has huge implications for IP management. The adoption of AI in patent analysis could lead to more robust and defensible biotech patents, raises questions about transparency, accountability, and the potential for AI to perpetuate existing biases in the patent system. As AI continues to evolve, its role in IP management will likely expand, impacting how patents are drafted, evaluated, and enforced. What is the future challenge in biotechnology patent law? There is a legal uncertainty. Rapid advancements in biotechnology outpace existing legal framework, leading to uncertainty in patent law. This is true for emerging fields like gene editing, synthetic biology, and microbiome research. Courts and patent offices must grapple with novel questions about the scope of patentability, definition of inventiveness, and the balance between innovation and public interest. Then there are also challenges of ethical and social issues, the ethical implications of patenting life forms. Genetic material and biotechnology process continue to provoke debate. The moral acceptability of patenting human-related discoveries, access to essential medicines, and the impact of biotech patents on biodiversity are likely to remain at the forefront of legal and policy discussions. Then there is a challenge of global harmonization. Differences in patent laws across jurisdiction pose challenges for biotech companies operating internationally. Efforts to harmonize patent laws regarding the treatment of biotechnological inventions will be crucial for reducing legal uncertainty and fostering global innovation. Achieving such harmonization may be difficult, but due to varying cultural, ethical, and economic considerations. Now, let us discuss about the impact of open science and open innovation on IP, and also there is an impact from the citizen science. Open science movement promotes the free exchange of data, research materials, and publications to accelerate scientific discovery. While open science can lead to more rapid innovation, it challenges traditional IP models that rely on exclusivity and secrecy. Companies and researchers must find ways to balance the benefits of open science with the need to protect their inventions through patents. Open innovation involves collaboration across organizational boundaries, allowing external ideas and technologies to complement internal R&D. In the context of microbial biotechnology, open innovation can lead to breakthrough discoveries by leveraging diverse expertise and resources. It also complicates IP management, as multiple parties may contribute to an innovation, raising questions about patent ownership rights and revenue sharing. There is a shift in the IP strategies. As open science and open innovation gain traction, biotech companies may need to rethink their IP strategies. This could involve embracing more collaborative approaches to IP, such as patent pooling, cross-licensing, or the use of defensive publications to prevent competitors from obtaining patents. The challenge will be to strike a balance between fostering innovation and maintaining a competitive edge in the market. So, with this we come to the end of today's lecture. Thank you for your kind attention.